Hello, I'm not just a speaker. I listen, I learn. I even argue sometimes. That's NLP for you.
Machines don't speak human, and human don't speak binary, but there's a bridge, natural language processing, or simply NLP. NLP is the science of making a machine read, understand, and generate human language, not just text, but meaning and even context. NLP has two brains. One understands language, that is natural language understanding. The other writes or speaks it, that is natural language generation. It's in your chatbots, voice assistants, spam filters, and auto generated subtitles. NLP isn't perfect. It can misunderstand or it can be biased. That's because human language is messy, emotional, and sometimes irrational. That's what makes building NLP systems both powerful and human. It's not about words, it's about the meaning. Now that we know what NLP is, let us look at where it is used. A system can recognize if an input text is a happy text, sad text, or even a sarcastic one. This is known as sentiment analysis. Social media platforms can detect and flag hate speech. It can even remove them. This is called toxicity classification. Named entity recognition helps us identify important tags in a document. Tags can be names, places, dates, etc. We use Google Translate to translate from one language to another. This is machine translation and is an application of NLP. Spam filtering. Gmail knows what mails are spam and what are not spam. This is another application of NLP. We have tools in text editors that can correct our grammatical errors, typos, and even awkward sentences. Finally, chatbots and voice assistants use NLP to converse with us. Before a machine can make sense out of text, it has to first clean it. This is known as data pre-processing. Now, let us look at a few data pre-processing techniques. Stemming is a pre-processing technique that trims the word to its root by chopping off its endings. Imagine we are trimming these names into their nicknames. Let's say we have Samarth, Samuel, and Samantha. They all can be trimmed down to Sam. This need not be accurate always. While university and universities might belong to the same concept, universe is completely different. But the stemmer doesn't know that. It just cuts everything down to UNIVERS, whether it makes sense or not. Limitization is a more intelligent way of reducing words to its roots. Instead of cutting, it uses grammar and a dictionary. It knows that better comes from good or was from be. Sentence segmentation breaks large blocks of text into sentences. This sounds easy, but take this sentence for example. Mr. Smith goes to school. He teaches science. Mr. here is an abbreviation with a period. Now, should we consider this as an end of the sentence? The computer has to figure this out. Stop word removal is a technique where conjunctions and articles are removed because they are repeated everywhere. It's not that these words are unimportant, but the machine does not need these words to understand meaning. In tokenization, we break the sentence into words or even small text fragments called Engrams. Why do we do this? Is because machine learns from very small pieces of text. Now that the text is clean and broken into pieces, it has to be converted into something that the machine can understand. Numbers. That's what feature extraction does. It gives structure and value to language. Let us explore some feature extraction techniques. Bag of words is a simple technique. It counts how many times a word appears in a sentence or document. Now let's talk about term frequency and inverse document frequency. Term frequency is the number of times a word appears in a document divided by the total number of documents. Take this document for example. I love pizza. Pizza is amazing. Pizza every day. The word count in this document is 9. Pizza appears 3 times. So the term frequency would be 3 by 9. That's 0.33. But here's a twist. Some words appear in every document. They're not special. That's where inverse document frequency comes in. It gives more importance to rare words rather than common ones. Inverse document frequency is the log of total number of documents divided by the number of documents containing the word. Assume these 3 documents have the following text. I love pizza. I love mountains. The burger joint. Using the IDF formula, we observe that pizza has a high IDF as it appears only in one doc, and the word the has a low IDF as it appears in all the docs. Now combine both. Term frequency tells us how frequently a word occurs in a document, and inverse document frequency tells us how rare a word is across all documents. Word to vector and global vectorization are feature extraction techniques that convert each word into a list of numbers. This list of number is called a vector. It learns meaning by understanding which words appear nearby. Once we clean and convert words into numbers, the next step is to learn from it. NLP uses 2 types of learning, machine learning and deep learning. Both of these help us to predict, classify, and generate text. Logistic regression is one of the simplest NLP classifiers. It predicts the probability of a label using a weighted sum of features passed through a curve called the sigmoid function. It's ideal for simple binary tasks like spam filtering, sentiment classification, and filtering out toxic comments. Naive Bayes is another classic classifier. It uses Bayes' theorem to compute the probability that a text belongs to a certain label. Posterior probability is the probability that the input text belongs to a particular category or class. Prior probability is how often this label occurs in general before seeing any specific text. Likelihood is how likely it is that this specific text would appear if it came from that label. Evidence or marginal likelihood is the overall probability of seeing this text no matter the label. The naive part, it assumes all words are independent, which isn't true, but the model still works surprisingly well. It's lightweight, fast, and often used to find bugs in our code. Decision trees work like a series of yes or no questions, branching out until they reach a decision. It's like playing 20 questions with your text. It works well when you've extracted clear features like word presence or sentiment score. LDA is an unsupervised learning algorithm used to uncover hidden topics inside documents. Think of each document as a soup. LDA reverse engineers the recipe by tasting the ingredients, identifying which flavors dominate each bowl. It is powerful to analyze large text collections like news archives or research papers. Hidden Markov models are probabilistic models used to predict sequences, like parts of speech in a sentence. They rely on both visible words and hidden states. In the sentence, she runs quickly. The observed states are she runs quickly, but the hidden states are pronoun, verb, and adverb that are parts of speech. Hidden Markov models are especially useful in tagging and speech recognition. Now, let us look at some of the deep learning methods used for NLP modeling. Convolution neural networks scan text in fixed sized windows, learning important patterns in phrases or word combination. It's like using a magnifying glass to spot key phrases. CNNs particularly work well for sentence classification, sentiment analysis, and intent detection. Recurrent neural networks process text one word at a time, remembering what came before. That's what makes them ideal for sequential data, like listening to a sentence word by word and remembering the story as it unfolds. RNNs are used in speech generation, voice assistants, and translation. Autoencoders compress and reconstruct text. They're used to clean, reduce, or simplify language. It's like summarizing a sentence, then trying to rewrite it word for word. Input, this is a noisy sentence, and the output would be, this is a noisy sentence. Denoising autoencoders are great for typo correction and data compression. Sequence to sequence models are used when input and output are both sequences, like translating a sentence from English to French. These models are used in translation, chatbot responses, and summarization. Transformers are the backbone of modern NLP. Unlike older models that used to read a sentence one word at a time, transformers read the sentence together as a whole, using a concept called self-attention. Self-attention lets the model figure out which words in a sentence are most important, not just based on position, but based on how they relate to every other word. It's like reading a sentence and instantly knowing which words depend on each other, like connecting the dots in real time. Language connects us with humans, but now it connects us to machines as well. NLP is just the beginning.